am joined today by Leah Curry, president of Toyota Manufacturing Indiana, where she's responsible for stamping, body weld, paint, plastics, assembly, conveyance, and plant engineering. Toyota's been investing in electrified vehicles for over the past 20 years, but of course the shift from the internal combustion engine to batteries and electric motors is still well underway. So I'm curious what key challenges remain in that shift.
So yeah, the shift to electrification, we're going to have probably 70 different types of electrified vehicles out by 2025. And, like I said before, Toyota, from a hybrid standpoint, has produced more hybrids than all other manufacturers put together. Really the shift is when you look at the battery, right? The battery is going to be heavier depending on what type of electrification you're looking at. So you have your battery for your hybrid, you have your battery for your plug-in hybrid, you have a battery for your BEV, total electric vehicle. And what we're looking at now is how do you process some of these types of new weighted batteries into your line. So currently we build hybrid vehicles, and obviously it's getting a battery, it's getting an inverter, and that's different than a gas vehicle. So you have to process your assembly line to be efficient no matter which vehicle you're building. And currently we look at the different ways that we can have attachment points on our end effectors of either if it's a transfer device the team member is using to set the battery, or if it's a robot picking it up and putting it in. We're looking at how to best lay out our processing in order to be very efficient, no matter what type of vehicle that you're building, because it's going to take all types of vehicles to really meet the demand of the customer. And we're looking at ways that we can build different types of electrification vehicles in order to meet the customer demand. So that is an ongoing analysis that we're doing really globally to take care of these different new technologies coming and to be extremely efficient and competitive building them.
Now I'm curious, of course, retooling is important for assembling new models at the Princeton plant. So what in your experience goes into ensuring a successful retooling process?
Well, step one is learn from your past. So what problems have you had with your current equipment or previous equipment that needs to be designed into the new equipment? We call that Act One. So we have Act One and Act Two. And Act One is design in for success. So all of our experiences, anything that's caused us downtime in the past, anything that's caused repetitive, frequent stops. So you can have a frequent stop, which is 15 seconds, 30 seconds, versus a major failure, which is could be 20 minutes. You take all that learning, and we have a process where we feed back to our North American production engineering team that is helping design the equipment that's coming in for our new products, and we feed back all those learning so that when we're designing the equipment for these two new models coming in, we don't make the same mistake twice, right? So it's the key, then don't repeat. No repeat. So we don't want to repeat any designs that didn't hold up or needed a lot of maintenance to maintain it or sustain the equipment. So we're constantly looking at how to Kaizen the equipment and then not repeat. So we call that Act One. And then Act Two is basically how do we take anything that's administratively controlling either the process or the equipment and learn from that as well. And we put in ways to be able to monitor and let us know if there's new issues coming up, which is more predictive. And that Act Two then will help us be able to plan downtime and not experience downtime. So we design in for success, and then we also put in our trending and our analysis and more of the 4.0 process so that our team members can make the best decisions at the right time to help keep us competitive.